हेलो स्टूडेंट्स, कैसे हो आप लोग। आई होप आप लोगों का ISI का एग्ज़ाम बहुत अच्छा गया। आज आपके सामने आपको दिख रहा होगा कि हमने ISI का 2026 का UGB पेपर हमारे सामने है और हमने एक्चुअली में UGA का पेपर भी हमें मिल चुका है और UGB का भी हमें मिल चुका है, बट अभी हम इस वीडियो में UGB के पेपर को एनालाइज करेंगे। अगर आप लोग अभी हमारा जो इस वीडियो में जो पॉइंट होगा वो यही होगा कि हम सिर्फ हर प्रॉब्लम को थोड़ा समझेंगे, skim over what the problem is trying to say, and we'll assign it a difficulty rating, which is going to be the point of this analysis video. But if you want a detailed solution video, so go into the comment section and tell us that. So I guess without wasting any more time, let's just get right into it. So this first question says, it's a two-part question. It says a comma b are real numbers such that this straight line is on the xy plane and passes through these 2 points. And it's given that all the coordinates of these points are rationals. So you have to prove that a and b are rational numbers with b not equal to 0. A very easy part. Like, this is just really easy, okay? And B is slightly difficult than part A, obviously, as compared to part A, because here the solution looks something like you get a coefficient matrix and you get a determinant which is in terms of all these coordinates x, y, y, I, for I from 1 to 3, and then you have to get the rationality of that thing through the rationality of xi, yi, all the xi's, yi's, and then you get that alpha and beta rational. So again easy, but part B is slightly difficult as compared to part A, but if I had to assign it a difficulty, I would say around 3 out of 10 at max. Let's go to question number 2. Sketch with reasoning the graph of this thing. So you analyze the graph, you analyze the point, you analyze the asymptotes, you analyze the behavior of this whole function. But all in all, this is again not very difficult, just 4 out of 10 at max. Alright, now question number 3 is slightly tricky, because here you have this basically log base x1 x2 squared, log base x2 x3 cube, all the way up to log base xn minus 1 of xn to the power n minus 1, xn to the power n, and then finally you circle back to 1 by x1 by saying that plus log base x1 to the power, this is log base x1 of xn, log base xn of x1. Okay, so this is a little mouthful, but you get the idea. So the question is this. Okay, and now what you have to do is you have to determine the minimum value of f of x1 all the way up to xn to over s. Okay, so this is just a little bit of mistake, but yeah. Now I have to analyze the difficulty of this problem. Now this problem is slightly difficult. Now why do I say that? It's because first of all, you will actually not analyze the sum, you will actually analyze the product of all these. Yeah, so what you will do is you will obviously, the thing is you can write each of these in a much simpler way. For example, you can write the first term as 2 times ln of x2 over ln of x1. Similarly, the second term is 3 times ln of x3 over ln of x2. And you go all the way up to the end and you will have ln of x1 over ln of xn. So you first convert everything into natural logs and take the power down. You will get a sum of these terms, right? F is basically nothing but the sum of these terms. Then you will analyze the product of all these terms and you will use AMGM inequality. Okay, you will analyze the product of all these terms and you will use AMGM inequality. And then you will basically, after you do that, you will get a condition on when the equality will hold. And that condition is again in terms of k, and you have actually the minimum value of the function comes out to be equal to n times n factorial to the power 1 by n. And this happens for a specific set of coefficients, for basically specific x1, x2 and all the way up to xn. Okay. Yeah, is there anything else? No. Okay, cool. Yeah, so this is, I would say, around 6 to 7 out of 10. 6 to 7 out of 10. Okay, so that's the difficulty I would assign to this question. So actually the thing is, I talked to a lot of students in my Telegram group and everyone has said that UGA was pretty good, but UGB was overall it was around 5 to 10 in difficulty, or at max 6 to 10 in difficulty. So we have a lot of students in our crash course and our other batches, and they all have said the same thing, that UGB is around 5 to 6 at max. Alright, so yeah, now this question, the part A is trivially true here. Then you have part B. Part B mein there will be like you could say a little bit of trick. You just have to like integrate twice and all that stuff and you will get 2 constants. But this question overall, I would at max give it out of like 5 at max out of 10. Yeah, 5 out of 10 in difficulty. Or you could push it to 6 because there's like integrating twice wala thing, but I don't think that's very hard to say. But okay, so let's just say 5.5 out of 10. Okay, this is best. Alright, next, this is a geometry question, right? So there was a figure printing issue. So there might be a little bit of issue in the printing of figure, but let me just verify if the statement of the question is correct. So this question was good. It was obviously a normal geometry question, but the steps were a little bit tricky. So the difficulty I would give it is around 6.5 to 7 out of 10. Because yeah, I mean there were some kind of tricks involved in this, using the fact that EFGH is a square and then you have to use the condition of perpendicularity and then finally you get the length of the radius. So yeah, this was a little bit hard to tally. So 6.5 out of 10 is good for this one. Alright, so let's come on to the sixth question now. So we say that let P be a polynomial of degree greater than or equal to 1 with real coefficients such that P of x is greater than or equal to 0 for all x. Then suppose that x0 is a root and show that there exists a positive integer n and a polynomial s with real coefficients. So this is actually again a very easy question. So first of all, you will write P of x is the P of x. Since we know that x0 is a root, we can write P of x equals to x minus x0 to the power m times some polynomial q of x. But the thing is that since P is always positive around 0, so using the fact that P is greater than or equal to 0 in the greater than or equal to 0 in the neighborhood of x0, you will basically get to the degree has to be even, and hence you will get this form. Alright, and hence or otherwise show that there exists polynomial q and x with regular coefficients are x greater than 0 such that for all x this thing holds. So again, not a very hard question. So I would give it this difficulty of at max 4 out of 10. Yeah, 4 out of 10 seems nice. Now question number 7. In this question, part A is actually very easy. Part A is absolutely nothing. Part B, you just have to use a little trick. You have to assume that these integers exist. You have to make these three numbers called b minus c over a minus b. Okay, and the second number L, you can make it to be c minus a over b minus c. And this third number M to be equal to a minus b over c minus a. And you will use that the product of these three is m. Sorry, product of these three is equal to 1. Hence, all of these are in the set minus 1 comma 1. And then using these facts and then progressing from there, you will get that these integers. This thing is not possible. This is the main trick here. And if you have accomplished coming up with this trick, your question is practically solved. So again, I would give this question a difficulty of 6 by 10. All right, so yeah, so the last question is question number 8. This question again is of the similar difficulty as question number 7. So first of all, you will show that this polynomial exists. Then you will show uniqueness, because if there are two, they both have to be the same degree. They both have to have a degree less than or equal to k plus 1. And they have to give all positive integers. So that means uniqueness is implied. So not a very hard part. B part actually might involve you to use the Bernoulli's formula to get the leading term of pk of x. But outside of that, I don't really feel like this question is any hard. So yeah, your coefficient will obviously come out to be 1 upon k plus 1. I would say this question is at max of difficulty 5.5 out of 10 maybe. Alright, so let's just see what difficulties we have assigned. And so all in all, again, the difficulty of the paper is between 5 to 6 out of 10, which agrees with what most of the students at the centers and in our crash courses said. And it also, agrees with what I think. So yeah, I guess this is all for today's video, guys. Do not forget to comment your thoughts on it. And also, if you want detailed solution video, please let us know and we will give you the detailed solution of the whole ISI UGB paper. The analysis of UGA is also coming very soon, but this was UGB's analysis. And yeah, thank you. Bye-bye.